Assalamualaikum warahmatullahi wabarakatuh, and a very good day to Madam Hayati binti Yaakob. I'm Nurzalifah, and today I'm going to initiate the presentation for our last assignment MAT097. So please enjoy our presentation.
First and foremost, I would like to introduce you with all of my team members, Muhammad Akil, Muhammad Nabil Mahadi, me, Nur Zalifah, Nurul Mahira Zaida, and Aku Adlina Batrusha. There are 2 tasks we have done. The first task entitled Population Growth in China from the year of 2001 to the year of 2009, while the task 2 entitled Trapezoidal Rule. Task 1 Population Growth in China from the year of 2001 to the year of 2009. Introduction part. We carried this task is actually to fulfill the objective of this course, which is to achieve CLO2, PLO3, CLO4, and PLO7. We have studied the topic of application of differential equation. Next, we move to the background study. The meaning of population growth is the change in the population over time, which also can be quantified as the change in the number of individuals or any species in the population using per unit time for the measurement. China has the highest number of population in the world, which is it ranks the number 1 in the list of countries and dependencies by population. In the mid-year of 2020, China also estimated to have 1,439,323,776 people according to the UN data. As we have found the current population in China, the latest one, which is on Sunday 12 April 2020, the people of the population is 1,438,116,346 based on worldometer elaboration of the latest United Nations data. The resource is for the China population 2020. Our research also found that China population has begun to decline and is rapidly aging, and its economic vitality will keep waning from the National Interest 2019. It is also very essential for us to use the population estimation from the China because it will help us to fulfill this project by using the application of differential equation. Move on to the problem statement. China had a significant increase regarding the population of the citizen from the previous years. Some factors give greater impact to this increment, including rising cost of raising children, higher housing prices, and competition for quality education. Lastly, it is because of lack of daycare facilities. There are 3 objectives for our assignment. The first one is to identify the population number in China for the year 2001 to the year of 2009. The second one is to model the population in China with first-order differential equation based on the Malthusian growth model. And the last one is to estimate one past and future population number using particular solution, and we compare it with the historical data.
Hi, my name is Adina. Now I'm going to continue with the scope and limitation until the calculation part. For scope and limitation, our study is performed in China and we focus for 9 years, which is from 2001 until 2009. And the applications of first order differential equation is the mathematical method used. The parameters that involved in the study are P, which is total population at time t, K, which is constant of proportionality, and A, which is a constant. The software that we use to plot graphs are Microsoft Excel and Desmos. Moving on to the implementation, we use historical population data in China, that is secondary data, and this data is obtained from a website called macrotrends.net. After we extracted the data from year 2001 until 2009, we converted it into a table and also a graph plotted using Microsoft Excel to show clearer trend of the population growth. Here we present table 1 regarding the historical population data in China from year 2001 until 2009. According to this table, we can conclude that the number of population in China is increasing from year to year. As for the calculation part, we applied the theory of Malthusian model in our calculation. From this theory, we learned that rate of population growth is directly proportional to the total population of the country at that time. Simply said, if rate of population growth is high in the country at certain moment, then the total population must be high too. After calculating by applying few steps of solving the differential equation, we managed to find out the general solution as well as the particular solution. Then, we used the particular solution to estimate the population number in China from year 2001 until 2009 by substituting t value. Then, all the values are transferred into a table, which is table 2, to show comparison between the actual or historical data with the estimated one using particular solution calculated just now.
Assalamualaikum and hi, I'm Nurul Mahira Zaida binti Zainal Abidin from class F12, group 3. So I will present data analysis, factor affecting of population growth in China, the thing that might affect population growth in China.
Data and analysis, figure 1 graph of number of population in China versus year from data. According on the line graph above, we can see the number of population in China rise dramatically from 2001 until 2009. This is the reason why the curve of the graph is directly proportional. Figure 2, graph of number of population in China versus year. Based on the graph, the population growth accelerates as year increase. The exponential curve indicates that there is no limit for the number of population increment. The curve in figure 2 is steeper than figure 1 because the particular solution does not consider factor affecting the population growth. Conclusion, we determine the number of China population in 2020. We got a 1,464,325,342. Next, we determine the number of population in 1999. We got a 1,282,863,410. The calculate value indicate a higher population than the historical value, either in past or future. The inaccuracy might be because of some factors that lower the historical value as compared to the calculate value such as immigration, economic development, and education. Next factor affecting population growth in China. First, good health system. Healthcare system in China has improved, especially in the big city and hospital. So it helped to reduce the rate of mortality in China, ultimately increase the population in China. Second, the higher fertility rate. The most significant demographic factor in assessing population growth, the process, and population development pattern, in particular the current and future population size and age structure. The thing that might affect the change of population in the future is the peak of population growth in China. According to the survey, China population is expected to peak in 2023. So the government of China compulsory two-child strategy in October 2015 to full rapid population growth in the country. The two-child strategy can reach 90 million women of reproductive age who had at least one child already. In the conclusion, due to overpopulation, China needs to make a two-child policy in their country to ensure the population in China is stable.
My name is Muhammad Nabil Mahadi bin Faizal. Now, I will present a subtopic of Math 097 project assignment, which is the task 2. And our title for task 2 is the trapezoidal rule. Task 2, numerical methods. There are many types of numerical methods such as Simpson rule, Newton-Raphson rule, and lastly the trapezoidal rule. Trapezoidal rule, or other name is trapezium rule, is quite related to a trapezium shape. So according to Euclid, the Greek mathematician, Euclid felt that trapezium is a quadrilateral but a little bit broader than a parallelogram. Nick Treverton, the British mathematician. So the segment means that trapezoidal rule has been used in many years in order to solve or approximate an integral. Besides that, trapezoidal rule also belongs to a class of formula called Newton-Cotes rule. In numerical analysis or mathematics, trapezoidal rule or trapezium rule is a technique for approximating the definite way integral. It divides the area under the graph into trapezoidal segments. So Figure 3 shows the graph or the construction of a composite formula from trapezoidal rule. So n is the number of segments the graph will be divided into, and h is the width of the segment. So the formula is h, which is width, is equal to b minus a, upper limit minus lower limit, divided by number of subinterval. Trapezoidal rule will be applied for each segment, and the sum of each segment is equal to approximation value of integral. So the objective of task 2, the first one is to derive the trapezoidal rule of integration in order to visualize how the trapezoidal rule occur. Second, to find area under the function when subinterval n equal to 6. Later we will see in the question. Third one, to find area under the function when subinterval n equal to 8. And last but certainly not least, to compare the result of integration between 6 subinterval and 8 subinterval. As you all know, the result may be different, but the differences are too small. So the scope and limitation. The scope of our study is the finding area under the function given when the subinterval equal to 6 and 8 in the interval of 0 until 1.5, which is given in the question, while our limitation is the technique that can be used to solve the function, which is only trapezoidal rule. Other than that, the calculation template also need to be done by using Microsoft Excel, and our graph must be plotted by using Desmos implementation. For 6 subinterval, divide the interval from 0 to 1.6 into 6 subinterval we equal with. Next, we simplify the equation if the equation can be simplified. The third step, we create the table like the right one so that we can find the value of s and the value of fs. From fs value, we times it with coefficient. The sum of the fs times coefficient, we times it again with the width, which is 1/4. Final answer is actually the area under the function.
My name is Akil. So in my part, I will explain to you guys about 8 subinterval and for data and analysis. 8 subinterval. The interval was divided into 8 subinterval and the result I got is 0.1875. And then we calculate the area of the region and the result is 2.622154358719. And the total for coefficient fs is 27.86424. For data and analysis in figure 4, as you can see, the example graph of fs with 6 subinterval using trapezoidal rule, while figure 5 is graph of fs with 8 subinterval using trapezoidal rule. In the figure 4, there are 6 trapezium under the graph, and the figure 5 is there are 8 trapezium under the graph. The trapezoidal rule works by approximating the region under the graph of the function fs and also to find the exact value of a definite integral by using numerical method. Under this rule, the area under a curve is evaluated by dividing the total area into little trapezoid. So for the both figure 5 and 5, the height of the rectangle are based on the height of the function at the left and right end or midpoint of each subinterval. The width of each subinterval for the figure 4 and 5 are 0.25 and 0.175. The result of the graph in the figure 5 has more deviation than the result for the graph in figure 4. So we can draw conclusion that graph in figure 5 are more accurate than the graph in figure 4, because the more subinterval that have been used, the more accurate the result that we got. There are 8 trapezium under the curve in figure 5 and only 6 trapezium under the curve in figure 4, showing that the number of trapezium is directly proportional to the number of subinterval. One way to increase the accuracy of trapezoidal rule is to increase the number of segments between A and B. In this procedure, we divide into equal segments and apply trapezoidal rule over each segment. The sum of the result obtained for each segment is the approximate value of the integral. Total area for all segments calculated for figure 4 is 20.83784 and for figure 5 is 27.86424. We can conclude that figure 5 is more accurate than figure 4 because of the total segments. Task 1. Throughout the task 1, we'll be able to discover a particular solution of differential equation for China's population growth based on data obtained. We'll also be able to plot the graph online and obey the hypothesis, which is the population increase over time based on our prediction. In task 2, we had learned new type of integration called trapezoidal rule. The rule is applicable when there are no other ways to integrate the equation. Find out that trapezoid graph is series of points with straight line. Able to find the area and the function given at subinterval of C and A as the area increase with increasing segment numbers. For task 1, broadening the scope of growth and not only focusing on population are the recommendations that can be taken into account. While for the task 2, recommendation that can be made is by increasing the number of sub-intervals in order to obtain more accurate results.